Hey, all you factoring fanatics. We are back here and we're going to learn the last type of factoring. I know you've all been clamoring for it, just saying, hey, when are we going to get to that last method? Well, here's the day. Mark it down in your calendars. We are focusing today on factoring a trinomial, which we've learned how to factor certain kinds of trinomials by unfoiling. But today we're going to learn kinds that have a coefficient out in front of the x squared other than just 1. But to see the difference in what we've learned and how we need this new method, let's just take a look at these warm-up problems. So part A here, factoring this, of course we still go through our progressions. Is there a GCF I can take out? No, there's not. It's got 3 terms. So I'm going to try to unfoil that because it just starts with x squared. That's really the key of what is going to make a new problem versus our old type of problem. If it just has x squared, I'm able to do this. Just go x and x, and we've been taking that for granted. And then I'm looking for 2 numbers that multiply to negative 24 and add up to negative 5. What multiplies to negative 24 and adds up to negative 5? Negative 8 and positive 3. I don't care about the order, of course. And so there we go. And we could, of course, FOIL that out to check that becomes x squared minus 5x minus 24. But you can take my word for it. That's correct. And if you don't take my word, go ahead and FOIL it. Part B, factoring this. Now remember, the first thing you should look for is there a GCF I can take out? And especially now, this is when it's going to become important, especially if you see something in front of x squared, you should be hoping, try and take that out. So can I take 2 out of all of these? Yes, I can. So that's good. That means it's an old kind of problem, really. I can take 2 out of everything, so 2, and on the inside will be x squared plus 7x plus 10. And then I'm just looking to factor this trinomial further. And that trinomial just starts with x squared, which is why it's an easy unfoil problem. X, what multiplies to positive 10 and adds up to positive 7, plus 5, plus 2. Easy. Cake, right? Okay, so now take a look at this example. Notice you've got a 2x squared there, and is there a greatest common factor you can take out of all of these? No, besides 1, of course, which doesn't help you. So this is what's causing problems. You've never actually had one like this before. So I'm going to talk about 2 different ways to do it. And it doesn't matter to me how you like to do it. Different teachers teach different ways. One way to do it is to still approach this as, look, it's a trinomial, and I'm just trying to unfoil it. What foils to give you this? The problem is that we've all been just going x and x when it's x squared, but now it's 2x squared. So you've got to think about what goes here that could multiply to give you 2x squared. And that's not too bad because there's only one combination. That really means one of them must be 2x and the other one must be x. But now, these 2 numbers here, remember, when you FOIL, always multiply to be this constant on the end of negative 3. Now multiplying to be negative 3 also doesn't have a lot of combinations. It could be 1 and negative 3, or it could be negative 1 and positive 3. But here is what is different, is where do I put them? Because if I put the minus 1 with the 2x, that's different than if I put the minus 1 here with the x. Or is it positive 1 and negative 3? And then where do I put them? So this is what makes this a little more complicated. Now some people will just do this. They'll just, and you can get good at this, doing this mentally actually, they'll just put the, take them and throw them down and then FOIL to check. Maybe they'll do it mentally, maybe they'll actually write it out the first time. So I'm going to use a pencil here. If you put plus 1, maybe just go with positive 1 and negative 3, and you put them right there in that order. Watch why this one doesn't work. And it's not the first and the last that you got to check with FOIL. 2x times x squared, and the last is 1 times negative 3, that's negative 3. It's the outers and the inners. if you multiply those outers, you get negative 6x, and you multiply those inners, you get positive 1x. And remember, when you combine your outers and inners, that always gives you what's in the middle. And ours is supposed to add up to negative x, negative 1x. And these two add up to negative 5x. So that means that's a bad combination. And I'm going to totally switch spots here, because if I had gotten, say, positive x instead of negative x, which is what I want, that means I would have had the right two numbers, but maybe I would have had the signs reversed if you get the opposite of what you're really after. So I'm going to put, maybe I'll put the +3 here and -1 here. And now when you do that outers and inners, 2x times -1 is negative 2x. 3 times x is positive 3x. And what do those combine to give you? 3x minus 2x gives you positive x. I want it to add up to be negative x, which means I got very close. I just need the opposite signs. So it means I'm going to keep the numbers where they are, but I'm going to switch the signs. So this is really supposed to be, oh, whoops, that's the combination I already did. I'll make that -3, and this one +1, and just watch why that works. Because now when you do the outers, 2x times 1 is positive 2x, and your inners, negative 3 times x is negative 3x, and that gives you the negative x you're supposed to get in the middle. So you know that has to be the correct combination, 2x minus 3 and x plus 1. The problem with doing this method is that this was a fairly easy one because 2x squared really only had one combination, 2x and x. And -3 didn't really have that many combinations either. But the more combinations they have, if for example this was 12x squared and this were like a -8 on the end, that's a lot of combinations. It could be 12 and 1x, it could be 6 and 2x, it could be 4 and 3x. The 8 could be 8 and 1, 4 and 2, and then you got to check all the combinations. So a lot of people don't like this method. It works, that's actually how I learned it in school, and you do get pretty fast at mentally going through the combinations. So if you kind of like that way, go for it. I don't care how you get there. I actually use a combination of them now. I mean, sometimes I will still do this mentally because that's the way I learned it in school. And sometimes I do this method, which I'm going to show you, which I would say most kids like because it takes away some of the guessing and the checking approach. Now this method is called the AC method. So in terms of our quadratic here, you know, A, B, and C are those coefficients. Now this still requires you to look and see, can I take out the greatest common factor? No. So when you're going to use this method is if you have a coefficient there other than 1. So if you got something in front of the x squared and you can't factor it out, this is when we use the AC method. Now it's called AC because the very first step in it is let's multiply A times C. That's doing AC. So 2 times -3. I know this seems very random. You would never figure to do this on your own. 2 times -3 is -6. Now what I do is I look for two numbers that multiply to be -6 but add up to be the middle. So that's kind of like our old traditional, unfoiling approach. We just had to do 2 times -3 first to get this new number, and that's why throwing the 2 in the mix affects this. So what two numbers multiply to be -6 but add up to be -1? And remember, you got all those combinations of 6 and 1, 6 and -1. And if it's negative, one of them's got to be negative. Could be 3 and -2, could be -3 and +2. The combination that adds up to -1 is -3 and +2. If you can do that, then you've done all the guesswork. Now here's what you do with those two numbers. We take this problem, 2x squared, and instead of the -x that's in the middle, I'm going to rewrite it using these two numbers. these two numbers that I just had to figure out. So negative x, I'm going to rewrite that as negative 3x, and the positive 2 as plus 2x. So I just took that and rewrote it. And then I still have the minus 3 on the end. So look at what I did. Negative 3x plus 2x is still negative x, so I haven't done anything mathematically illegal. But I just found a way to rewrite the middle term. And you know what I did now? I created 4 terms. And how do I factor things with 4 terms? I use grouping, and that's what we've been working on lately. So if you're good with grouping, you might like this approach, and that's why a lot of kids do like this approach, because all you had to do is come up with those 2 numbers, then you can rewrite the middle with them. And now I go about my grouping. What can I take out of these? I can take out an x, and I'll have 2x minus 3. What can I take out of this group? I can only take out a 1, and in this case I want to take out positive 1 because there's a plus in the middle. And as always with grouping, you're hoping to have that common quantity that you can factor out, whether you like to put it at the back or at the front. But there's your 2x minus 3 that's in common. Factor that out. And the other factor is x plus 1, those coefficients, x plus 1. And there you go. Same answer that we got here, 2x minus 3, x plus 1. So it doesn't matter to me how you get there, but I'm going to include a second part of the video where I do 2 more examples if you just want to get the hang of this and you know, give it a shot. So otherwise, just watch, rewatch, ask questions if you have them.